TV from Other Dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey everybody, how are we doing? It is Monday. What day is it? It's Mega Mondays. You know what day it is. This is Wazzle Mega Mondays right here. Classical Mega Mondays right there. Let's hop in here and start talking about class. I had my second cup of coffee. Have you had your second cup of coffee today? We're going to hop in here and start talking about class. If you're in the chat, feel free to say hi. Oh, I was going to send really announcement. Let's go ahead and send the announcement. The weekly review. We're currently live. We'll see if anyone hops into the chat right here. And let's start seeing. We've got the test coming up right here. The test is on Wednesday. A little bit of assignments to tonight, Canvas content, all that good stuff. Let's hop over here to the main screen. Now, if you have a conflict with the test, please tell me as soon as possible. We'll get it rescheduled. The test is usually given earlier. That's why you say, hey, Mary, good to see you here. Feel free to have any questions. Let me know. You can see the test coming right up here. And I believe we have Mubot. You can help us out with this?
I am Mubot.
Mubot's going to help us out with here. Review 2. I believe Mubot knows that command right here. Mubot, are you awake in the chat? Are you awake? He might not be awake right now. Oh, I think he posted it. We should see review 2 here in the chat. So Mubot's posting a link. Mubot, you on that? Oh, there we go. Go here for test review 2, Mubot says. Let's click Mubot's link. And with Mubot's link, we're over here on test review 2. I was worried the page wasn't going to load there. So the link is in the chat right now currently with the test review information. You know what let's do? Let's make sure everyone's got this. And let's go here with the upcoming tests. Let's make sure everyone sees this. Someone might not be watching this video. So let's go here, review material for test 2. Just a reminder, the Stats 1 page has review material for the upcoming test. Click here. Click here. And then let's copy the link into here. And there we go. I think we're good to go. Let's test the link. If you have questions, let me know right now. The link does work. Let's go ahead and drop this right here. And actually, there is a link for test 3 already. It's on the page right there. I'll drop this. Well, let me not put it in the chat. Someone's going to click that and learn test 3 material. If you go to the page and you go to review material exam 3 right here, you will be on the review material for exam 3. So everything is already located right here. Those buttons are looking a little, really button? You're going to do that? Let's see what the WordPress site is doing. It's being a little weird today. But yes, you can see all of the stuff. Now, the projects are not what we're doing. Do not click on those projects. They are different. Did we remove them? Good. Don't do that. Don't do that project. So everything posted right here. Exam, review material 2. Review material 2. Make sure to be doing this. If you have questions right now in the chat, let me know. But the review material is very important right here. We could do some review questions right now. You've got topic playlists going down here. We'll do a Kahoot. The exam's on Wednesday, so we'll do a Kahoot tomorrow night. I'll send out the announcement about that. But if you're looking over the topics, oh, it choked up here for some reason. If you're looking over the topics, you can do decision trees right here.
For the test, how many donuts
going through. Brian's talking about the topics. Tell how good of sampling methods. It's one of the most watched videos actually on the YouTube channel, interestingly enough.
Play fantasy football.
Going through. Oh, Brian's laughing about something. So here we are, the systematic sampling. But check out the videos right here. Just some classic review. If you have questions in the chat, just let me know. If you're like, hey, Brian, I'm wondering about this right now. Where's the review at? What's the test going to be on? Everything's posted right here with the test material and the practice test. So you can see the formula sheet, which you can have printed out or written out. But let me know your questions if you have them. But yeah, we'll see how everyone's doing. Let's give out some points. Wake everyone up in the chat right there. Well, I think that's got it for what's going on with the test. Mubot's giving out those points. So what are people thinking? We've got right here the assignments coming up due. You know what? Should we do a Canvas content? If you're in the chat. Wait, the Kahoot is tomorrow night, not during exam 2 review tonight. Oh, we have the exam review tonight? You know what then? Let's do it tonight. What time do I have that scheduled for tonight? I forgot I scheduled these things way ahead of time in advance. So Mary, let's do that. I confused someone with it last time because I'm sorry, this summer's been a whirlwind. Mary, you know what? Let's do it tonight right here. So what time do I have that tonight? Let me go check. And let me send out, it is at 7 p.m. So it's 8 p.m. your time tonight. So we are doing it tonight. We are going to review tonight. So you are correct. It is at 8 p.m. tonight. So let's do it tonight. So it's 8 p.m. your time, right? Or you might be in Central like me. Are you in Central? You know what I'm going to say. But it should probably be 8 p.m. Knoxville time, right? The Eastern Coast time. So I think you're right. Let's do it tonight. We'll send out a reminder to everybody like, hey, the Kahoot's starting soon. And this way we can have a little bit more time to review, I think, too. Sorry, I forgot I made these at the start of the summer. And then my brain's been going a mile a minute. I'm currently teaching 3 courses right now. So, but please ask questions, like perfect questions right here, Mary. So this way, I think I caused confusion last time because I changed it. That's my fault right there. That's user error. But how does that work? Does that work well for you, Mary, tonight? Are you going to be at the Kahoot? We'll be reviewing. I'm in Nashville, so Central. Yeah, so you and I both are at 7. If you're not on Central time, then it'll be 8 p.m. for you. If you are Central time, then it will be at 7 p.m. But great questions, Mary. Yep, we'll do it tonight. We'll do it because we've got it scheduled. We've got it in the books. I planned out the whole semester for Stat 201 full session right here, and then I changed the date of it. You're welcome, Mary. Well, thank you for asking. That's how things occur. And I totally forgot that I had like made that stream already. I'm like, oh yeah, I've already got that in the books. So I'd really feel bad if people went and be like, you'll be there. You got it. I'm going to try to pull in some competition for you, though. I'm going to try to pull in other students who maybe going to try to win the prizes. So there's prizes, $20 first prize, $10 second prize. So you're going to have maybe some competition. I hope. It might just, who knows, it might just be you, and then we'll see if you win. But, we'll see how many people join in. Might have some people joining in from some other classes. You never know. If we have people from other classes join in, I always make sure a 201 person wins a prize. So just in case we have, so 320 is always welcome to play to review their knowledge. But if that happens and the leaderboard is all 320 students for some reason, and they're just there to review, we make sure a 201 student wins a prize. Because that's, they should win because it's their class. So they'll win something at least. What questions do you have right now? Mary, I'll let you, if you have questions about a chapter, about a quiz, about a Canvas content. What are you working on right now? What do you want to know more about? Last week was 5th of July holiday, so we weren't here last week. So I was like, you know what? Let's take the holiday off. I was like, I took one day off. It was one day. So what questions are there right now? Feel free to go over the Canvas content. Can you talk about this material? Can you explain this concept? Can you go more in depth on the text? I'm going to hop back here to Spice. Let's do this. So whatever you're wondering about right now, it is your time to pick the avenue we go and what we talk about here. We'll be doing... Let's send out we just sent out a bunch of announcements. We'll wait a little bit on this. Let me set an alarm. Set an alarm for 6:50. Kahoot. Kahoot is in the books. If you have questions right now, it is question time. Mubot, you want to appear here in space? I should make Mubot. Mubot, say hey to everybody.
I am Mubot.
He doesn't want to appear there anymore in space. He's not there. Which I focus on most for the exam. Probably one of the hardest chapters is chapter 13, where you're dealing with the sampling distributions of the sample mean and the sample proportion. Someone's like, I have no idea how to do that chapter. On the test, will we be using the applet, or we just need to read screenshots again? Reading screenshots again. So I think would be great. Let's do like an example question. So one of the questions, so Kendall, thank you so much for swinging by. Let's throw out some points here. Throwing out some 50 points, going crazy right there with the points. I'm gonna pull up the practice test right now and look at one of the similar questions that you could be like working on similarly. So let's do this. Let's go open the practice test right here and take a look at like one of those types of questions. Okay, heading over to the practice test. What's the test going to look like? Great question. So we are with the practice test, even though it's 5 years old, still off of the same thing. Now remember, it's going to be similar to your Canvas content questions, and it's going to be similar to a little bit like my Pearson, but I think Canvas content's your number one way of thinking what it'll look like. So hop onto Canvas content quizzes, make sure you know how to do those. The better you're doing on Canvas content, usually the better we see people do on the test. Probably one of the biggest questions people ask are those chapter 13 questions. And this one right here is a really good chapter 13 question. So let's take a look at it. The owner of a new apartment building must install 50 water heaters. let's say the sample proportion of all always hot water brand heaters that will last 10 or more years is 0.25. So we're saying like, we know that 25% of these hot water heaters last at least 10 years or more. We can think of 50 always hot water brand heaters that this owner actually owns, buys as a random sample from all of them. So they're just randomly buying these. They're not buying the good ones. They're not buying the bad ones. It's completely and utterly, wait for it, random. So after 10 years, the owner goes by, the owner will know the proportion of the water heaters out of 50 she purchased that actually last 10 years. This proportion can be thought of as a sampling proportion because they're going to see from a sample of 50 hot water heaters what proportion lasts 10 years. So the first important question is going on right here. In the example, the sampling distribution of the sample proportion refers to what? And it's basically a theoretical idea. So the theoretical idea right here deals with if you buy 50 hot water heaters, the proportion of them that will still be good after this period of time. So the distribution of all possible sample proportions from sample size of 50. So it's like, what could theoretically happen? So kind of let's talk about this visual here for a second. When we say what could theoretically, that's a totally different exam. Don't look at that. It's for another class. They've got exams too coming up. If you were to take, these are all hot water heaters. Like one of these little dots right here is a little hot water heater type thing. And if you were to take 50 of these dots, like 50 random dots through here, like you're just going to take 50 of them. 50 of these hot water heaters is what you're taking. Just each one represents a hot water heater. So you're just going to take 50 of them. And you would get your sample of 50, a whole bunch of hot water heaters there, a bunch of 50 of them. Now, what we're talking about is theoretically what could happen here in your sample. And the distribution we see is it possible, let me just ask you, is it possible that all the hot water heaters could last 10 years? Is that kind of theoretically possible? Like think about this, only 25% of them last 10 years. Is it theoretically possible that if you took 50 of these hot water heaters, they could all last 10 years? Is that theoretically possible? We can kind of do a tangential question to this, but just think about it. Is it possible that every hot water heater, and this is just a machine type thing that heats up the water, it eventually might break. Apparently 25% of them last 10 years. Is it theoretically possible all 50 of these, we took a sample of 50 of these, so we just went in here and took 50 different of them. So we're just going to take 50 of these dots. Like those are the dots we take. We take 50 of them. Is it theoretically possible that they could all last 10 years? Remember, they have a probability of lasting 10 years. Don't worry, this is not a trick question right here. They have a probability of lasting 10 years of only 25%. But is it theoretically possible? And we can do another type of question on this. Let's see here. We got two people in the chat at least. Do you think it's theoretically possible? This theoretically, not likely, but theoretically possible. Like, sure, you could win the lottery, but you're probably not likely to win the lottery. Is it possible that every water heater we take could last the full 10 years? Is that theoretically possible? What do people think? Just theoretically possible, not like it will happen. Totally. Great job, Oscar, right there. Earning everyone. We're just going crazy on the points. 50 points. Thank you, Oscar. Totally theoretically possible, but not likely. Does that make sense? It's not likely. I don't think that's going to happen. When we talk about this, we're talking about the sampling distribution of the sample proportion. How do we know that this is proportions? Because we're asking a categorical question. Does the hot water heater last 10 years? Yes or no? So when we evaluate this, we're simply looking at a hot water heater and we're saying, did this hot water heater here last 10 years? Yes, or last 10 years? No. And we know the truth for the population, which is P. If you have questions on notation, please let me know. P stands for, if you had all the hot water heaters, the truth is that 25% of them would last the 10 years. Like if you had every single one, we make millions of them apparently. So if you had all of them, you would find out for all of them, on average, they last 25% of the time for the 10-year period. So 25% of them would be in the yes category. So your 50 could be 25 right here. Now I want you to think of it as the problem this way. If we did this, and this becomes a multiplication problem now, hint, what is the probability the first water heater lasts 10 years, and the next hot water heater lasts 10 years, and the next hot water heater lasts 10 years, and the next hot water heater lasts 10 years? Does anyone hear what I'm doing? can you think about the probability that all 50 last 10 years? Like the first one lasts 10 years, and the next one lasts 10 years, and the next one, and the next one, and the next one. What would this eventually solve out to if you looked at the probability that the first one lasts 10 years, and the next one lasts 10 years, and the next one lasts 10 years, because they're independent. Each hot water heater doesn't care about the previous one. What would you say right here is the probability of the first one lasting 10 years, the next one lasting 10 years, and the next one lasting 10 years? And we're converging on a different topic right here because this is the rules of multiplication, the multiplication rule, to find the probability that 50 hot water heaters all last 10 years. So they each have an individual probability of 25%, but I'm going to put in the chat for you to see, the probability is simply 0.25 raised to the 50th power. Does that make sense? It's like the first last 10 years and the next last 10 years and the next last 10 years. So they all last 10 years, and that'd be very unlikely. Like that's a decimal thing that is very, very tiny. So I really don't think we're going to see this. It's theoretically possible, but not very likely. Now we get into the chapter 13 part of this, where hopefully it starts to be like, okay, this is what we've been doing. So now that we understand what we're trying to understand, we're simply taking and erasing all those points. We're saying if the hot water heaters last 25% of the time, then what percent of the hot water heaters would you expect to last 10 years? This is not a big question right here. Like if I told you 80% of students at UT are in-state, let's go talk to 50 students. What percent of those students would you expect to be in-state? So just answer this question. 80% of UT students are in-state. If you go and talk to UT students, 50 of them, what percent would you expect to be in-state? 80% of UT students are in-state. If you talk to 50 UT students, what percent would you expect to be in-state? Then we'll look at the equation on this and understand what it means. 80% of UT students are in-state. That's the truth. I'm telling you 80% of UT students are in-state. And then I ask you, if you go out and take a sample of UT students, what would you expect to see? So if you took a sample of 50 UT students, similar to our question here, what percent of those 50 UT students would you expect to be in-state? And that's what this equation is asking right here. That's what I'm saying. What is the expected proportion of your sample? That's what that reads. What would you expect to see in a sample? That's a simple proportion. If you went out and took 50 students and you know that 80% are in-state for the whole population. 80% of UT students are in-state. And if you take a sample of 50, what percent of that sample would you expect? Just expect, not saying it will be, just saying 80% of students are in-state. So I would expect in a sample to see what? Promise not a trick question. Promise not a trick question. So we know the truth. We know that 80%, like the registrar told us, they said, our records show that 80% of UT students are in-state. We know this. That's a fact. And that's what the top thing means here. This means it's a fact about the population. That means this is truth. And Kendall right there, amazing work, earning everyone another 20 points right there. Oh, I might have hit it twice. We'll find out if I did. So this is what we put the sample proportion equal to, or the expected value of the sample proportion. We would expect to see in a sample, not saying we will see that, but in a sample, we would expect to see this. So think about our example here. We're doing the same thing. Well, we know the truth. So if we know the truth, then we would just expect in a sample to see this right here. Oh my gosh, I cannot write. And so right down here, that is where the mean of the distribution is at. Now, 2 letters. As I'm writing this out right here, I want you to think every normal curve needs a mean and also needs a variation part of it. So we need the mean and we need the variation. So I'm going to write it like this right there, sigma, but I want you to tell me what sigma is. So the, whatever that is, I want you to think, because that's the this of it, it's the spread of it. So we have here the sigma, which is going to be P times Q over N square root of the whole thing. P times Q over N square root. I always do that big thing right there to make sure we know it's over the whole thing. So when we have P right here, that's just the true proportion, and Q is the complement. So P is 0.25, and Q is whatever adds up to 1. So all you do if you want to find P and Q is just subtract from 1. So if P is 0.25, you'll go 1 minus 0.25, and you'll get Q. Just make sure they add up to 1, and you'll see them both right here. 0.25 times 0.75, they just add up to 1 right there. And then we're going to divide by the sample size, And this will give us the what of the distribution down below. So taking p times q over n square root finds us the what of the distribution. We have now just found the what. We have now just found the standard deviation or the variation, how far out the curve is spread. Because we usually go out 3 standard deviations. So we're going to go out 1, 2, 3. 1, 2, 3. And so let's find this value of p times q over n square root. Calculator, you want up here? You're going to, oh, what are you doing, calculator? P times q over n square root. There you go, 0.06. I'm just going to round it for the time being. Don't round on your test. It's just going to make my decimal places easier down here with my really bad handwriting. There we go. And now we have the variation of what we would expect given 25% of 50 hot water heaters would last 10 years. This is now the curve down here with a mean and a standard deviation as follows. And you can see right here within normal variation, within plus or minus 2 standard deviations, we would see about 13% all the way up to 37% would occur about 95% of the time when we take a sample size of 50. So that's the middle 95%, which is pretty much the most likely, and that's just plus or minus 2 standard deviations. And we're just doing our classic mean plus or minus standard deviations right here. So when you look at this question and what it's asking, go back to the question over here, we need to know some conditions right here, which is what we were assuming. And condition 1, oh man, TLR live, condition 1 is my favorite condition. And the first condition, which we mentioned, is that all these hot water heaters are being selected randomly. We don't want to go and just take the bad ones or the good ones. We're selecting random ones because if we take certain ones, they won't have the proportion that the population has. If we say, oh, let's just go take the bright shiny ones, or let's just take the ones that are, they don't want us, like, are broken or something, then they won't have the same proportion we would expect given the population proportion. So we would randomly select them. So did the question say random? Let's go here, look. And the way we pass this condition right here is we take a random sample. There we go, random sample. Boom, pass the random sample. We did pass random sample, so we're good. Condition 2 is 10%. This has to deal with finite populations. It's actually a rather complex condition, which goes into the error we get when we oversample. So it's a little bit confusing right here, but the 10% condition states that you must sample less than 10%. And it only matters on finite populations where you could oversample, and it gets into a very complicated error calculations, which go kind of more than we need. So the 10% condition here would be passed, and why? We must sample less than 10% of the population. So we have to look at this right here and ask, are these 50 hot water heaters less than 10% of all hot water heaters? And the answer is yes. How about our 80 UT students? Are 80 UT students less than 10% of all UT students? And the answer is yes. 80 UT students is way less than 10% of all UT students. It's probably like not even 1%, because if we had 1% of UT students, we have like 30,000 students, that'd be 300 students. That'd be 1% of UT students. We're nowhere near 10%. So we pass the condition by sampling less than 10%. And that's counterintuitive because it just deals with the error calculation on finite populations. You're not meant to know the whole error calculations on finite populations thing. The condition is 10%, sample less than. The last condition right here is based on the type of data. I'm probably going to show a graphic here in a moment to hopefully help out this. But you'll notice right here we have, there's 3 conditions: random, first condition, 10%, and the third condition right here will be the success failure condition. Let me go to space real quick and grab my graphic on this because it'll really help and show you what's going on. A little bit of music, chilling out. Let's go ahead and grab the graphic. Heading over to Stat Nation right here. 201. Do we change the name of the channel or do we archive channels? Ah, I found it. I found it. Okay. A little visual learning help right here. Okay, we are good to go. Let's head back down to Earth. Let's do it. So, conditions are one of those things you just have to memorize. You have to sit down and you have to know how the conditions work and for which one. So we were just talking about the success failure condition. The two conditions that remain static are random, we randomly select our observations, and 10%. We select less than 10% of the total population. I just call it the 10% condition. Now, the conditions that change are data dependent, because if we're dealing with categorical data, we'll be doing the success failure condition. If we are dealing, let me draw some arrows on this. If we are dealing with quantitative data, we'll be dealing with the nearly normal large N events. That's the other part of chapter 13 on sampling distributions for the sample mean. If we have the chi-squared distribution, we'll be dealing with expected cell count. Now, there's no order to these, but I do like to keep them in an order to help keep my memory straight on which condition goes where. So this is just the third condition, or part of the conditions, if you do the chi-squared, random, 10%, and then expected cell count. But you can tell by the color coding down here, this is also for the chi-squared test of independence, which is a later chapter. We have not gotten to any of these conditions yet because we do not have two variables. If we have two means, we'll be doing independent means. And also, you notice the color coding here, this is for quantitative data. So categorical data, quantitative data, chi-squared test of independence. This is a good review sheet right here just to help out with the conditions. So take a note on this right here, pause the screen, take a screenshot with me off the screen, but this should help understand which conditions and when to use them. But we always use randomly collect our data, less than 10% of the population, and then it really becomes data dependent. And then the next condition would be, are you dealing with two variables? What's going on right there? Good stuff. Let's go back to space and then back to the question. So where were we in that question? Here we go. Oh, quick right there. With this question right here, we are going to then ask, what is the mean, the standard deviation, and also the shape of the distribution? If we pass the conditions, and we've done it right here, if we pass the condition, then we'll have normally distributed data. The mean of the distribution will be the true mean. So these formulas right here, just to show them again, without the values in place, would look like the following. We're going to put the values in place right here. The mean for the distribution of the sample mean is P, and the standard deviation for the distribution of the sample mean is P times Q over N, quantity square root. But we're going to put those values back into place that we found, and this is about 0.6 or so, 0.6175, I believe. We have it on the calculator here, 0.6123, 0.6123. And we've used that here as the distance. So this value you calculate inside of here becomes the distance between each interval down here. That is the distance or the standard deviation. The value you calculate right here becomes the mean of the distribution, the very center of it. Hence, this is the mean for the value of our sampling distribution, what we expect to see when we take a sample. And think, 25% of hot water heaters last 10 years. So if I take 50, well, I'd expect 25% of them to last 10 years because 25% last 10 years. So from 50, I expect 25% to last 10 years. Let's go back and take a look at the question again. Where'd you go, question? There you're at. And so suppose after 10 years, she finds that 16 out of 50 hot water heaters last 10 years. Calculate the sample proportion. This one's nice and easy right here because when we do the sample proportion, the formula for the sample proportion is X over square root of N. So we're going to take right here, and X is the number of successes. She had 16 that lasted 10 years. And then N is the number of trials. So she had 50 total. And X over N equals P hat. And this is what we observed in a sample. Like, oh, I saw in my sample 32% or 0.32 as a decimal, 32% of my hot water heaters last 10 years. Now, notice where that's at. With our drawing right here, which is key, and we can draw this out on our sheet of paper, scratch sheet of paper, you'll notice that it's just a little over one standard deviation above. It's right about here, which doesn't seem that unusual. It's not more than 2 standard deviations away. So this observed P hat right here, this is her observed P hat right here, is the observed P hat of 0.32. Notice where it hits down on the number line. So we don't need the David M. Lane. We can just draw this out right here for ourselves. And let's look at the next question. Using your answers from part 3 and 4, calculate the z-score for this observation. So now we can get an idea of the z-score by looking at it. This z-score, who knows in the chat? I'll give the chat a moment. this z-score is going to be between what and what. Just visually speaking, before you give an answer, this z-score for this observation is going to be between what and what. And the z-score formula is going to be observation, so we observe a p hat, minus the mean, which is p right there, over p times q over n square root. So that's going to be 0.32. Oh, Mubot's talking to us all. And then this was what we found a moment ago, 0.06. Let's go look at it. 1, 2, 3. So if you look visually where this is at, we have to get a number between 1 and 2. So we're right here on this line, and it's between 1 and 2. Let's see if we get that. So this is a good check for us. Wrong number. And then we divide, and we get 1.14. Looks to be about where we're at. So that means we're 1.14 standard deviations above the mean, and that is where we're at right here. 1.14 standard deviations above the mean. It's not that unusual. That's kind of a common, slightly high. Like, imagine if we went to complain, they'd say, well, that's not that unusual to have 31% of your hot water heaters break when you expect 25. Given your answer for part 5, would you consider 16 or more hot water heaters unusual? And the answer is no. It's within 2 standard deviations. And this is what we were pointing out earlier, is that 2 standard deviations, and this is our justification for it, 2 standard deviations is kind of our bounds for normality. At least what we would expect 95% of the time according to the empirical rule of the 68, 95, 99.7. So if you look at how we're kind of working through this right here, you can see how these questions can be solved without the applet. Now, the applet does make it easier, but try drawing these out, try writing them down for yourself, and try the practice test problems. I've got videos going over the practice test, but please ask, be like, hey, Brian, I don't understand this. But there are videos if you want a quick help for the assignments. We'll put the review in the chat again. This is some 474. So if you have questions, so much work. If you have questions right now, let me know. We're just going to take a look. Oh, we're on the review page here. Here we are. And if you're wondering about any of those questions that I've been going over, there are questions right here going over it. This was question number 6. So you can see a video review of question number 6 right here. Sample proportion. Yep, sampling distribution sample proportion. So this is a good 5-minute video. Might work through it a little more quickly and just explain the concepts. Here we are on the conditions. Hey, it's more Brian right there. So just going through conditions, talking through, explaining them, a little more written out. So if you want to review these right here, but try to work the problems yourself. Here's where we found the sample proportion. And then here's where we find the z-score, which we just found. And then going through here, we find if it's unusual or not unusual and talk through it right here. So these are another way to practice and make sure you have your knowledge, but nothing really substitutes just sitting down, trying to work through it, seeing where you get stuck, then going look at the answer and reviewing it again. Try to work it out. Practice, practice, practice. Let's hop back to space. Here we go. So that's kind of an example of what you could see on the test right there. What questions are there right now? Let me know your questions. We'll be back here in a little bit playing some Kahoot. Oh my gosh, I can't believe it. Summer is about 2/3 done. It just flies by. Go ahead and catch some Pokemon today. My gosh. It'll be the start of the school year before we know it. It'll be pretty exciting stuff. But if you have questions in the chat, let me know. We'll have a big review session for project number 2. Thank you so much for people informing me. I forgot that we had the video for tonight, so I was like, oh yeah. It's a big streaming day today. We had class, office hours. But feel free, and I want to put this out there too, feel free to hop into any office hours you see me on. Even if 320 or 474 or 475 has a question right now, let me know. But if you're ever in the chat and just like, hey, Brian, I have a question, don't worry. Just throw that question in the chat. And we're here to help, reply, and respond. I'll probably hop over to Discord and answer some emails here in a moment. But feel free to reach out, because sometimes you don't even know what to do. You're just like, Brian, I'm stuck. I don't know what's going on. But just say, hey, Brian, I'm stuck. I don't know what's going on. I'll say, okay, cool. What do we need to cover? What do we need to talk about? We'll play one more song here, and then we'll end. Let's end on this right here. This is one of people's favorite songs here. Be a big review tonight. We'll start prepping for that review. Get some practice in. And definitely dedicate some time. We've got the review videos posted. I think that's got it. Well, if you have questions, let me know. Kind of a, not that big of an assignment week this week. More of a test week. Because it is test week. Points. You know what, Mary? Let's throw out some 50 points. 50 points right there. Oh, it full screen too. I got to rebind these keys. If I unfull screen. Why not? I'm going to unfull screen. I put the points to... I probably don't use those F8s. Should just bind them over there. There we go. Well, with that, we'll be back later. I will see people for the Kahoot. I'll send out a reminder. Until then, 7 p.m. Central, 8 p.m. Eastern, 6 p.m. Mountain Time, 5 p.m. West Coast. I'll see everyone later. Bye for now, Puppet Shark. Where you been at? Later. Puppet Shark, don't be all... What you doing? Bye for now, everyone. Bye!